Hello children, welcome to Zero Panic Maths. In today's session, let us start with a new chapter, chapter 3, the world of numbers. Okay, now as an introduction of this chapter, there is some history of the numbers, that how the numbers were invented, who invented, all that has been given. Okay, now imagine the olden days when there were no numbers uh, there for counting the objects. Okay, so assume that you don't know the numbers only, then how did they manage to count the objects, and how did they invented the numbers which are naturally used for counting is the story behind the history given. Okay, so the history that I am not including that as part of this session, you can read it from the book. Okay, but we can start with one example of one-to-one correspondence for counting. Okay, so assume that in olden days, so I'm taking an example of counting the cows in a cattle hut. Okay, so this example is also given in the book, you can read that, but I will simply explain that what exactly is that example. Okay, now assume that there are some number of cows in olden days when there were no numbers. Okay, you have to assume that there are some x number of cows in the cattle hut. Okay, and assume that they will leave all the cows during the morning to in search of the food, and when they come back in the evening, then they will again push them to the hut. Okay, but during this situation, if suppose if some cattle are missed, okay, if some cows did not come back only, then how do they come to know that there are some cows which are missing? Because they don't know to count it. Okay, so assume that you have 10 cows and 9 cows only came back, because they don't know the numbers, it is difficult to identify that. Then how did they manage to do that? They actually used to have as many, for one cow they will have one small stone, okay, or some small pebble. Okay, and say there is some container in which they will actually place one stone for one cow going out. Okay, suppose one cow is going out, they will place one stone pebble inside that container. Okay, there is one more cow is going out, then they will place one more pebble inside that. So that way, for each cow they will place the number of pebbles. They don't know to count the pebbles, but for one cow they will have one stone. Okay, and keep it in that container when the cow goes out. Okay, now suppose in the evening when each cow comes back, then they will take out one pebble for each cow going inside the hut. Okay, and finally in that way, finally if this container is remaining with some pebbles inside that, then they will assume that okay, so there are some cows which are missing and they did not come back. Oh, so this way of counting one-to-one correspondence. So this is called as one-to-one correspondence for counting. Okay, and this act of matching one object to another, we are actually matching the cow as an object to the stone pebble as another object. Okay, so matching one object to another object has given birth to the natural numbers. Okay, so the numbers which are used usually for counting is called as natural numbers, and that is a set of natural numbers represented by the letter n, and the numbers involved in that set of numbers is 1, 2, 3, 4 and so on. You understood this? Okay, now you might be knowing what exactly is the natural number, but this is what a simple story behind how did they might have invented the way of counting some objects naturally. Okay, so since these numbers are used for natural counting of objects, these set of numbers is called as natural numbers. Remember this is a very first set of number system or the world of numbers. Okay, and okay, now this is starting with the introduction. In this section of introduction 3.1.1 and 1.2 3.1.2, there are some history given some numbers or some markings are carved onto the bones, and that was also one way of counting the numbers or objects in the system. So there is an history given, you can read that from the book. And there is some other history given regarding the Indian context, how did the trading and astronomy were involved in the way of counting the numbers and the world of numbers, how they invented, how they did they evolved. All that history is given. Okay, I'm not going to discuss all that. So you can read it from the book. Okay, so this is a simple introduction of world of numbers. Now let us have some exercises or examples, simple examples only. There are no complex examples involved in this, and simple basic arithmetic operations only are involved in these examples. Okay, so this is exercise set 3.1. Let us read the problem, and this is a very simple problem. Okay, listen carefully. A merchant in the port city of Lothal is exchanging bags of spices for copper ingots. Okay, now don't go by the words. What exactly is that? So you can assume that there is some trading merchant, and he is exchanging some bags of spices. He is a spice trader. Okay, bags of spices for some copper rods. You can say copper rods. Okay, he will give some spice bags, and in exchange he will get some copper rods. Okay, this is how in olden days the exchange of things used to happen. Okay, or purchase and sales used to happen. Okay, now he receives, now let us look at the information given here or the data given. He receives 15 ingots for every 2 bags of spices. So if he gives 2 bags of spices, they will give 15 such copper rods, assume that. Okay, so if he brings 12 bags of spices to the market, okay, then how many copper ingots he will leave with? Okay, so you can assume the given information as given is if 2 bags of spices. Okay, very simple. B is equal to 15 ingots, correct? Or you can say 2 is equal to 15. Okay, now I'm just writing that into numbers. Okay, so if you want the bags of spices to make it as 12 at the left hand side, then you have to multiply it by 6, correct? So I will say multiply both side by 6. It's a simple example only. Multiply both side by 6, both sides by 6. Why I am multiplying it by 6? I am just making that 12 bags of spices at the left hand side, which is 2 now. Okay, so similarly I have to multiply it by 6 on the right hand side also, just to maintain the equality of the equation. Okay, so it is 12 bags, 6 into 2, it is 12 bags is equal to 15 6 that is 90 ingots. 90 ingots. So this is what the answer is. You can write that into words. Okay, so that with 12 bags of spices, in exchange of that he will leave with 90 copper ingots when he leaves the market. So this is a simple example. There are multiple ways of resolving this. You can make use of any simple way. This is not the only way. Okay, so let us move to the next question. Look at the sequence of numbers on one column of the Ishango bone. So this Ishango bones example, as I discussed in the introductory part only, what is that Ishango bone, how the numbers were carved on the bones and all, that example was given in the introduction part. You can just look at those examples. Okay, so but now currently there is some sequence of numbers given here. Then they are asking, what do these numbers have in common? Okay, now first of all we have to identify what kind of numbers those are all, and what do they have in common, and list the next three numbers that fit this pattern. Now assume that if you are trying to identify the patterns between the given numbers, what are the given numbers? What are the numbers? 11, 13, 17 and 19, correct? These are the numbers, right? Okay, if you see carefully, then these numbers don't have anything in common. Okay, they are not factors, they are not divisors, they are not squares. Then what are those? Those are actually prime numbers. Okay, so if you observe, 11 is a prime number. What is a prime number? If you remember, prime number is a number which is not having any factor other than itself and 1. 11 cannot be divided by any other number other than 11 and 1. So 13, 17, 19, again all these are prime numbers. Okay, so what is the characteristic? What is these numbers have in common? Okay, you can say that all the given numbers are prime numbers. All the given numbers are prime number. So what you need to write is, so this is what they have in common, that they possess a characteristic of prime in all these numbers. Now what is the next thing is, next three numbers that fit in this pattern. So you have to write in this series only, you have to write the next three prime numbers that possess this characteristic. Okay, so what are the other prime numbers? The next three prime numbers, next three primes, you can say. So after 19, 20, 21, 22, 23 is a prime number, right? You know that, right? What is a prime number is? Prime number is a number that is divisible by itself only. So 23 cannot be divided by any other number. 24 is not, 25, 26, 27, 28, 29. 29 is the next prime number, which is after 23, and after 29 it is 31. 31 is also one such number which is not divisible by any other number other than 31. Understood this? So this is a simple example that you have identified the characteristic between the given series of numbers. Let us go to the next number. Okay, now you see that, see, this is a simple characteristic of the numbers that now we are going to explore. Okay, now question number 3, we know that natural numbers are closed under addition. Natural numbers are closed under addition. What do you mean by closed under addition? That they have given simply inside the bracket, you can see that. Okay, closed under the addition is the sum of any two natural numbers is always a natural number. If you take any two natural numbers, what are the natural numbers? Okay, now let us start with the solution only directly here. What are the natural number? The natural number set, you can mark it as natural numbers. You can mark, you know that, right? It is starting with number 1 and the numbers which are used usually for counting all are positive only. Okay, so it is a natural number set, and they are saying the sum of any two natural numbers. So among these set of natural numbers, you any two natural number you take and add it, because it is the addition operation, right? Let me take 2 and 4. If I take 2 and 4 and add them, what I will get is 6, and 6 is again a natural number, right? So this is simply what is called as the closure rule, or they can say that addition is the operation and closed under addition. Natural numbers, that is number n, is closed under addition, because when you add two natural numbers, you are going to get another natural number only. Okay, now the question is, are they closed under subtraction also? Are they closed under subtraction also? So what do you mean by closed under subtraction? Is if you take any two natural numbers and subtract from each other, one from the other, you have to get another natural number only. Then only you can say that it is closed under subtraction also. Now let us take some example. Okay, let me take 4 and 2, and if I subtract 4 minus 2 is 2. Okay, now subtracting 2 minus 2 from 4 is giving me a natural number only, but it is not true always. If I reverse it, okay, say suppose if I am doing it as 2 minus 4, then I will get minus 2. Okay, and minus 2 is not part of natural numbers, because natural number have only positive numbers involved in it, and negative numbers are not part of natural numbers. So it means that the subtraction is not closed, or you can say that natural numbers are not closed under subtraction. So the answer is the natural numbers. You can start with the word no. The natural numbers are not closed under subtraction. Okay, and what they need is they provide a couple of examples to justify your answer. Okay, so what this is one of the example. You can write this only. Okay, or else I can write example 3 minus 6 is minus 3, and minus 3 does not belong to, or you can say not part of, minus 3 is not part of n. You can directly write as minus 3 is not part of n. Or couple of example they told, one more example. You can write one more example, 2 minus 4, and minus 2 is also not part of n. This is very simple example, but this is based on the basic knowledge that you might you should be having based on the basic arithmetic operations. Understood this? Okay, so let us move to the next problem. Okay, now this is also some form of descriptive question only, but very simple. Okay, ancient Indians used the joints of their fingers to count. Joints of the fingers means, so we have fingers like this, it will be the counts like this. Okay, so they are saying fingers to count. So in ancient Indians used to count the numbers based on their fingers, and for each finger there are 3 joints. They are saying practice till today. We might sometimes we use, right, like 1 2 3 like this. We will use sometimes. So each finger has 3 joints. Okay, now as I already told, each finger has 3 joints, 1 2 3. Okay, 1 2 3 like this, and the thumb is used to count them. Okay, we actually don't use like this, but this thumb only is used like this: 1 2 3 4 5 6 7 8 9, like this they used to count. Okay, now then the question is, how many can you count on one hand? Okay, now obviously there are 5 fingers here, but one finger thumb is used for counting, so only remaining 4 fingers are used for counting purpose. Okay, used involved in the counting. So I start with 1 1 2 3 4 5 6 7 8 9 10 11 12. So 4 into 3 it is simple. Okay, 4 fingers into 3 joints. Okay, that is the answer here. Then how does this relate to the ancient base 12 counting system? Base 12 counting system means, in one hand if you can count 12 numbers, then one hand is equal to 12. Okay, 12 into 1, 12 into 2. Okay, so if there is some other person's hand, so they will count it as 12 into 3, 12 into 4, like that. Okay, so that is the base 12. So for every hand there is 12, so one hand is equal to 12, actually makes the base 12 counting system. That's all the answer is. Okay, so let us simply write the answer for this, that total fingers, total I can write it as total counting fingers is equal to 5 minus 1. Okay, why 5 minus 1? Because thumb is used for counting purpose. 5 minus 1 is 4. Okay, and given is 3 joints per finger, right? Per finger. You can write this information in any format. Okay, so I am writing as I am feeling it as correct to write it. Okay, you can write it in your own words. Only thing is you should be doing it as 4 into 3. Okay, so therefore total number of joints. What is the they are asking? How many can you count on one hand? Okay, so therefore the count in one hand is 3 into 4, that is equal to 12. So, and since in one hand you can count 12, that became the basis for the base 12 counting system. Okay, so therefore, or you can say, so this 12 counts or 12 joints, you can say 12 joints in one hand base 12 counting system. Okay, you can write these words also in your own words in any format. Understood? This is also a simple example only. All these are simple examples because the world of numbers itself is a simple concept. Okay, so there are different situations and concepts that might be coming in future sessions of the same chapter, but currently in the beginning we have very simple examples. Let us move to the next concept. The next concept is the revolution of shunya. Okay, when nothing became something. Okay, now till now we have actually used some system of numbers where only the positive numbers are used. Okay, now shunya, you might be known. What is shunya? Shunya is a Sanskrit word meaning nothing. Shunya means nothing, and that is represented by zero actually. Okay, so for example, if you have, so when you are trying to describe what is nothing or what is shunya, we simply use some real life examples, like say if you had 5 apples and gave all 5 away, or you ate all 5 apples, then you did not have any number to represent your state. Okay, now if you have 5 apples and you gave away all the 5 apples, how many apples you have? Okay, assume that there is nothing like zero, then how do you describe that how many apples you have? You have nothing. You have nothing. And what is the state that you have? Is the zero state or shunya state. That is what is called as. And actually Brahmagupta, a ancient mathematician, he actually explicitly defined this zero, okay, as the result of subtracting a number from itself. So example is a minus a is equal to 0, they are saying, but in general this example only you can consider. 5 apples you had, okay, and you gave away all 5 apples, so subtracting the number from itself. So what is the number that might represent this state is a symbol by that format, and that is shunya, or that is called as zero. And that is how the zero was invented, to represent a state of number which represents nothing. Okay, which actually means there is nothing left with us. Okay, so this is a simple history behind how the shunya was invented, the zero was invented. All that is again given in detail in your book. You can go through that also. Okay, but there are some fundamental laws of arithmetic related to the shunya are given here. You already know about these also, but explicitly you should be actually reminded that how you are getting the arithmetic operations done with the zero. Okay, so you can say first number, when zero is added to a number, the number remains unchanged. You know that. Okay, so for anything, if you add zero, the number does not change and it remains zero only, or it remains the same only. Okay, so in general, a plus 0 remains as a. Similarly, if you subtract 0 from a number, then the number again remains unchanged. So that is called as a minus 0 is equal to a. Okay, if you subtract 0 from any number, so this might be looking funny to you, but when you think of a situation when there was no number to represent or no symbol to represent 0, so that time they invented it, and they actually deduced some laws describing 0. Okay, so if you add 0 or subtract 0, the number will not change, it remains unchanged. That is what they says. Okay, but when you multiply 0 with some number, then it makes the number as 0. Okay, so here the result changes. Okay, adding and subtracting numbers, adding and subtracting 0 from any number does not change the number, but if you multiply any number with 0, it makes the whole number as 0. You know that also. Simply remember these fundamental laws of arithmetic based on 0, shunya. Okay, so now after inventing shunya, okay, now one more thing I actually forgot here. So when 0 was invented, this particular thing that what I am telling you is not actually given in the book, but it should be added. So after natural numbers n, okay, which is a set of 1 2 3 and so on for counting the objects, when 0 was invented, if you add 0 to this set, actually this set of numbers will be called as whole numbers, and this is represented by w. I don't know why, but this particular thing is not added in the new syllabus book. So you should be knowing this also, that after natural numbers, if you add 0 to that set, it will make it as a new set that is called as whole numbers. Okay, so whole number is a superset of natural numbers with 0 added to natural numbers. Okay, now after 0, what is the next invention done by Brahmagupta? That he did not stop there after inventing 0. Then actually he started thinking of more things, that that is subtraction of a number from itself is 0. If suppose subtracting a number from itself, it is making it as 0, then what might happen if you subtract a bigger number from a smaller number? That was his next way of thinking. Okay, so then he started, what happens if he subtracted a larger number from a smaller number, like this 3 minus 5. What is 3 minus 5? It is minus 2. But till that time, when only natural numbers and whole numbers with 0 was invented, till that time, again there is no way that can represent the negative value of some number. Okay, so in the number line, if you on the number line, if you think of, then keeping the 0 or shunya in the middle of the line, assume that there is a line horizontally drawn, and on the right of the numbers, right of the number line, if you are representing the numbers 1 2 3 4 by all the positive numbers 0, then at the left side you should be writing the equivalent value. Okay, quantity wise, the equivalent numbers only will be continuing in the left side, but with a negative sign, opposite sign. And that is what is been described or derived by Brahmagupta to represent negative numbers. And he actually gave some specific names to those. We actually call them as positive integers and negative integers. Okay, but they named it as specifically fortunes or dhana. Dhana is again a Sanskrit word representing positivity. Okay, or positive. Okay, similarly, rina is negative. Dhana plus rina is negative. Okay, and negative in general sense is a debt. Okay, okay, and fortune is positivity. That is what in general we call. Okay, now that is what is described here. Okay, I've already explained that. He recognized two states: fortune, which is dhana, positive numbers on the right side; negative, which is debt or rina, it is called as, and it is represented by negative numbers. And negative numbers are representing debts, and positive numbers always represent wealth or asset. In general, anything that comes in, okay, gives us the fortune, right? And that is treated as a positive value. Okay, and anything goes out from us, or anything that uh, has to be given in future, that is treated as a debt, and that is a negative number always. Okay, it's a simple thing that we need to remember. Okay, and finally, they have given the definition of integers, another set of numbers, and that is the combination of positive natural numbers that are towards the right side and their negative counterparts, these are towards the left side, okay, and zero. Okay, so this is in the middle of that. So all this set of numbers, the positive, zero, and the negative, is called as integers, and that is represented by the symbol z. Okay, don't represent it by I, it is represented by z because it is a German word zehlen. Okay, zehlen is numbers only. Okay, so how many different set of numbers we actually uh, described or studied now is natural numbers with 1 2 3 4 all positive values, okay, and then whole numbers with 0 and all positive numbers, and finally now we have seen z, which is integers, which is having a set of 0 positive values and negative values. You can say positive integers, negative integers, and 0. Okay, z represents all this. So what is, how can I represent the set z is 0 plus or minus 1 plus or minus 2 and so on. This way I can represent the integer z. Okay, now let us see what is the next thing that arithmetic based on the Brahmagupta's laws, arithmetic based on the integers. Okay, now this is also simple, you know all this, but mathematically how did they derived, that we need to know. Okay, now they are saying fortune means plus. Remember this before you go through this. Fortune is plus, debt is negative. Debt is negative. Okay. So fortune plus fortune is a fortune. They are saying if you add a fortune to another fortune, it is also a fortune. It means if you add two positive numbers, you will get another positive numbers. So that is, this is a positive number, this is a positive number. Fortune plus fortune is another positive number, that is also called as fortune. Understood? Very, very simple. Next, debt plus debt is a debt. Similar to fortune, it is debt plus debt is a debt only. So similarly, minus 5, and if you add minus 4 to minus 5, it will get you minus 9, which is also a negative thing only, that is debt. So it means that they have given it here. It means that if you have a debt of 5 rupees already and you have taken another debt of 4 rupees, uh, it will be a debt of 9 rupees in total. Correct? So that is what they are theoretically trying to explain you, that a debt added with another debt will make another debt only. Okay, similarly fortune added to another fortune will make a fortune only. Okay, now this is a simple thing, but here comes the different thing. Okay, so the fortune minus 0, so you know that already by the basic law of shunya, that if it is subtracted or added to any number, then it will not change the number. The number remains unchanged, and that is what the third law here. Fortune minus 0 is a fortune only. So the example is, so if 7 is a fortune, plus 7 is a fortune. If you subtract shunya from that, it will give you fortune only. Okay, it is a positive number. Similarly, a debt minus 0 is a debt only. You have minus 6 already and you subtracted 0 from that, it will remain as minus 6 only, and it remains as debt only. And now it comes the product. The product of a debt and a fortune is a debt. See, minus 3 into 4. So usually what we did studied is multiply the numbers and multiply the symbols also, or signs of the numbers also. Minus into plus becomes minus. That is what they are trying to say here. The product of a debt and a fortune is a debt only. Okay, so any negative number multiplied to a positive number gives the result as a negative only, because minus into plus is minus. You know about this, right? So in real time they are trying to explain that if you take on 4 debts of 3 rupees each, okay, so it means that there are 4 different debts of 3 rupees each. Okay, so minus 3 represents debt Try to understand here. Minus 3 represents debt, and how many such debts are there? 4 debts are there. So totally how many debts you have is 12 debts, and 12 debts is represented by minus 12. Understood this? Okay. So when you say debt, you give a minus symbol. When you say fortune, don't give any symbol, because it by default will have a positive symbol. Understood this, right? Okay. Now finally, and then the fifth law is the product of two debts becomes a fortune. Okay, so here comes the twist. Here also you know that minus into minus becomes plus. A debt multiplied with another debt becomes a fortune. Or in general mathematical sense, minus into minus becomes plus, and multiply the actual given numbers. Understood this? So these are the simple laws of arithmetic on the integers. You know already that. Based on this, let us have some examples. Exercise set 3.2. Okay, simple arithmetic operations only are involved in all these numbers also, in all these problems also. Okay, now let us start with this. The temperature in the high altitude desert of Ladakh, okay, is recorded as 4 degrees Celsius at noon. Okay, in the afternoon, it is 4 degrees Celsius. Okay, a temperature. Then by midnight, it drops by 15 degrees centigrade. Okay, read it carefully. They are saying it drops by 15 degrees centigrade. Okay, they are not saying it is dropped to 15 degrees centigrade. Okay, it drops by 15 degrees centigrade. It means that you have to subtract 15 from 4. Understood this? Okay, then they are asking what is the midnight temperature. Simple example. Start with given is start with given temperature at noon is equal to 4 degrees Celsius. Okay, and temperature drop by 15 degrees centigrade. 15 degrees centigrade. So it is equal to 4 minus 15. Understood? Okay. So what is 4 minus 15 then? 4 minus 15 is minus 11 degree Celsius. So that is the temperature at midnight. So therefore, the temperature at midnight is minus 11 degree Celsius. There is nothing complex in this problem. It is a simple mathematical subtraction. Understood this? Okay. Now let us see the next problem. Okay. Now let us see. Here comes the knowledge of what is debt and what is fortune. Okay. And how to represent them. Okay. Now let us see that. A spice trader takes a loan or debt. They are saying loan means debt. Okay, you have to give that money back, so it is always called as a debt of rupees 850. This is one data, remember this. Okay, the next day he makes a profit. When it is profit, so I already told that if it is profit, it comes in, the money comes in, right? So we say that it is a fortune, and fortune of rupees 1200. Okay, the following week he incurs a loss. So what do you mean by loss? Loss means negative, again a debt, loss of rupees 450. So there are three data that is given: 850 debt, 1200 fortune, and a loss which is also a debt of 450. Write this sequence as an equation using integers and calculate his final financial standing. Okay, simply let us start with representing this debts and fortunes in terms of integers. Okay, based on the knowledge that what we have studied theoretically. Okay, now let start with a loan of rupees 850. Oh, okay, so start with a loan of rupees 850 is equal to, so when it is loan, or they have already told it as debt, it should be represented by negative value, as I already told you. Okay, so it is minus 850. And then a fortune or a profit of rupees 1200. Okay, a profit of rupees 1200, profit of rupees 2000, sorry, 1200, so it is plus 1200. Okay, so it is 1200. Okay, now what next is a loss of rupees 450. Loss is considered under debt, okay, or negative number. And finally you can say the loss of rupees 450. Loss of rupees 450 is minus 450. So this is a sequence of events happened with some spice trader. Okay, we have to write this sequence as an equation using integers. So what is the equation? Therefore the equation, or you can say the required equation is, what is the required equation is minus 850 plus 1200 and minus 450. This is the required equation. And finally they are saying calculate his final financial standing. Now let us calculate these values. Okay, so 850, it is 1200 minus 850. What is 1200 minus 850? So if you subtract 850 from 1200, you will be left with 350 positive. Okay, so you have a profit of 1200 and 850, you already have a loan. So suppose you have given loan of 850, from 1200 you will be remained with 350, and but with 350 he incurs a loss of 450, that is minus 450. Okay, what is 350 minus 450? It is a larger number, so I am left with 100. So his final financial standing, you can write it as it is 100 rupees loss or 100 rupees debt, you can say. Okay, so can you write that? So his final financial standing is loss of rupees 100, loss of rupees 100, or you can say debt of rupees 100, debt of rupees 100, anything you can write it as. Okay, but don't write it here, you write this line at the end of this question or the answer. Understood this? Now let us quickly move to the next problem. Okay, now this problem involves some multiple sub questions inside this, but it is also a simple arithmetic problem only. Okay, calculate the following using Brahmagupta's laws. So Brahmagupta has given us some laws that minus, see, it is like you have to read it like debt multiplied with the fortune makes it a debt only. Okay, that way you have to read it. Debt multiplied with debt gives you 14, sorry, fortune. Okay, let us just directly derive this only. So how do I read this is 5 debts. Okay, let me write that. You have to also have to write this 5 debts of 12 rupees each, right? 12 each, or you can write here only. Okay, so 5 debts of rupees 12 each will actually give you 60 debts. 60 debts is equal to 60 debts. Correct? So you specifically write what is debt and what is fortune. Okay. So what is a debt of rupees 12 is, so therefore I can write it as of 12 rupees is minus 12. Okay, and how many such debts are there? There are 5 debts, and what is it actually derived to is 60 debts. Okay, so 60 I will write it as 60 only, but debt is represented by minus symbol. So therefore minus 12 into 5 is equal to minus 60 is the answer for the first question. Okay, similarly we know this also, that minus 8 into minus 7 is actually plus 56. Okay, but how do we actually represent it by Brahmagupta's laws is a debt into a debt actually gives us a fortune. Okay, so you have to write it like this only. Second one, okay, seven debts, seven debts of 8 rupees, seven debts of rupees 8 are all cancelled, all cancelled. Okay, so that will actually convert it into 56 fortunes. Okay, so that is actually converted into 56 fortunes. You can write it this way only. Okay, no problem. So 7 debts of 8 rupees each, so that is minus 8 into minus 7, which is equal to plus 56. So you can write it this way. Okay, minus into minus plus, and 8 sevens are 8 or 7 eights are, it is 56. Okay, third one. Okay, now third one, you can see that from 0 you are actually subtracting some number, and that is a debt. Okay, from, you can say, from third problem can be written it as cancelling 14 debts, cancelling 14 debts is equal to 14 fortunes. Correct? 14 debts, if they are cancelled, then they will be converted into 14 fortunes only. So therefore 0 minus of minus 14 is actually is equal to plus 14. 0 minus of minus 14 is 4 plus 14. Okay, now if you look at the fourth problem, it is a little bit different from all the other three problems, that you have a 20 rupees debt and you are dividing that 20 rupees single debt of 20 rupees into four different debts. Okay, then how many debts will be divided? There are four debts of 5 rupees each. Okay, so that is why we say that minus 20 divided by 4 is equal to minus 5. Correct? So 4 5s are, it is 20, and with negative sign it is minus 5. So it is 4 into 5. It means that sorry, no, 4 into minus 5, or you can say minus 20 divided by 4. So you can write it in the form of a generic way of description, that minus 20, or you can say minus debt of rupees 20, debt of rupees 20 is divided in four parts, divided in four parts or four debts of rupees 5 each, and that is also a debt only, that is also a debt only. So therefore debt of rupees 20, that is minus 20. So when you say debt, it is minus 20, and it is divided in four parts, that is divided by 4, and it will lead to 5 rupees debts, and that is minus 5. So it is minus 20 divided by 4 is equal to minus 5. See, you are actually going through the simple arithmetic operations that you already know that how to do it, but they are actually connected to the real life problems. And why we are studying this? Because Brahmagupta, when there was no invention of numbers at all, then he explained all these laws in real time examples that normal people can also understand. Okay, so that way of studying numbers is a world of numbers. That is what we are doing in this chapter. You understood this, right? These are all simple examples only, but you have to study it in the way that Brahmagupta explained. Okay, now this is also an example. I've already given the solution here. Okay, so this is also an example with real life. They want it to be explained. Let us read the problem. Say they are saying explain using the real world example of debt. Okay, this is an example of debt. Why subtracting a negative number, why subtracting a negative number is same as adding the positive number? You already know that, right? The example is 10 minus of minus 5 actually becomes 10 plus 5, right? It actually becomes 10 plus 5, and it the final result will be 15. Why is this so? They are asking why subtracting a negative number from a positive number, okay, is becoming is similar to adding that given number to the actual number and making it a fortune or a positive number. Solution is, suppose Rajesh have an amount of rupees 10. I'm explaining the problem. Okay. And this, with this example only, suppose Rajesh, there is a person by name Rajesh, have an amount of rupees 10 in his pocket. He already has 10 rupees in his pocket. And so he, okay, so I've written he here. It is not he, sorry, I, it is he. Okay. And he already owe rupees 5 to his friend Suresh. There is a friend of Rajesh by name Suresh, and he brought some money from him, and that is 5 rupees. Okay. So suppose if you have 10 rupees, or you say Rajesh has 10 rupees, but 5 rupees he has to give it to Suresh, then the financial status of Rajesh, then what is the financial status of Rajesh will be 10, and you are adding a debt of my 5 rupees. Okay, you have to give it, right? He owes it, so it is a debt, so minus 5, so that makes it 10, and adding a debt of minus 5, it is 10 plus minus 5. Okay, don't calculate the actual value, but this is how you represent the status of Rajesh, the financial status of Rajesh. Next, suppose we assume that, now assume that Suresh cancelled the debt because he is a friend of Rajesh. Say Suresh said, okay, don't give me that 5 rupees that you owe me, right? Don't give me that. Okay, he cancelled it. Then what happens? As I already told, when some debt is cancelled, that debt is actually converted as a fortune to us. Okay, so that actually the debt is now converted to a fortune. So that minus 5 becomes plus 5 to us, because that is a fortune. So that is the reason when you are cancelling it. See, this is a debt, minus 5 is a debt, and this minus is a cancellation. Here plus represents adding that debt, but here you are subtracting that debt or cancelling that debt. So that makes it a fortune of 5 rupees, and totally it makes it as 15. You understood this? So this is the reason minus of minus becomes plus. Understood this? Okay, and this is what Brahmagupta has explained, that debt of a debt is a fortune. Debt of a debt, or multiplication of debt to another debt, makes it a fortune. Understood this? Okay, let us see if there are any more examples. Okay, so there are no examples, such similar examples are there. Let us discuss this concept in the next class. Okay, thank you.